Okay, let's look at problem number 59 in 1-2. So it says interpret x minus 3 as the distance, the absolute value of x minus 3 as the distance between x and 3. So it's, right, x minus 3 means the distance between x and 3. So now we want to interpret that as the distance is in between 2 and 5. So basically we're saying here's 3 and here's x. Here's x, right? So we're saying that x could be either direction, right? We don't know where x is. But we're saying these distances are between 2 and 5. So let's try to figure out how we can graph that. So here's 3. I'm going to add some more numbers. 4, 5, 6, 7, 8, 9, 10. That should be far enough. 2, 1, 0, -1, -2, -3, -4. That should be far enough. So again, we're saying the distance from x and 3, or 3 and x, is more than 2, right? It's more than 2, but less than 5. So let's just physically count. So here's 3. So 1, 2. I'm going to put open circles because we're not including endpoints. So 5 would be a distance of 2. So 2, 3, 4, 1, 2, 3, 4, 5. And 8 would be a distance of 5. So if the distance is in between 2 and 5, then x is actually in between 5 and 8. Does that make sense? So the distance is between 2 and 5, but x itself is in between 5 and 8. But technically we can do the same thing on the other side. So we could be 2 away in the other direction, which would be 1, or we could be 5 away, which would be -2. So x could also be in between -2 and 1. And so if we solve this algebraically, you should get the same answer. But it's nice to have an idea of the visual interpretation. Another option is to solve it algebraically. The absolute value doesn't quite work for the in-between because we have to make all these different cases. So we're going to solve them separately. So we can say 2 is less than the absolute value of x minus 3. And when it's in between, that's an and, not an or. And the absolute value of x minus 3 is less than 5. So and means we're going to find the intersection or the overlap of the solutions. And the reason we need to make 2 of these is so we can use this rule. So I'm going to rewrite this one as x minus 3, absolute value greater than 2. So we can use those rules for absolute values. So x minus 3, absolute value greater than 2, means x minus 3 is greater than 2, or x minus 3 is less than -2. Because it means this physical piece should be bigger than 2 when we take absolute value. So -3 would be bigger than 2 when we take absolute value. So then we're going to add 3 and add 3. We get x is greater than 5, or x is less than 1. And I will shade this one in orange. So greater than 5 goes this way, less than 1 goes this way. So that's my solution. But because we have an and, we need to find the overlap with the less than 5 case, right? In between 2 and 5 means they need to both be satisfied. So let's solve this and see. So we have a less than, so now we can say it's in between. Absolute value less than 5 means the distance is in between -5 and 5. So we can add 3, add 3, add 3. What do we get? We get -2 is less than x, which is less than 8. So let's graph this one in, I don't know, purple. So -2. And these are all open circles because the endpoints aren't included. And we're going to go to 8. And then now the solution is just what do they have in common? So I would find the pieces of the interval that they have in common. So that would be from -2 to 1. And that would be from 5 to 8. So that's how we would solve this algebraically, which I actually thought maybe visually was faster. Same answer, right? But anytime we have these in-betweens, it creates an AND event. Let me know if you have questions still.